Hello everyone, you're welcome to Mathematics Tour. In this video, I will solve all the Igcse questions on circle geometry in 2029. The first one is question 8 from paper 058021 May June 2019. A, B, and C are points on the circle center O. Find the obtuse angle AOC. So the obtuse angle AOC will be this angle from here to here. That is the obtuse angle. Then the reflex angle will be the one outside here. Okay, so that is reflex angle. So we need the inner angle. So we know that the reflex angle AOC, so let's write up here, AOC will be equals to 2 times ABC, that is ABC, because this is angle as center, okay, subtended by the arc AC is twice the angle as circumference, that is angle ABC. So we can find the reflex angle AOC. So that will be 2 into bracket 130 degrees. Okay, so if you expand the bracket, you're going to get 260 degrees. Okay, but we need the the obtuse angle. So this is the reflex angle. Okay, so we know that the reflex angle and the obtuse angle add up to 360 degrees. So we can say that the obtuse angle AOC, so let's write obtuse, okay, angle AOC, so will be equals to 360 degrees minus 260 degrees. So that will give us 100 degrees. Okay, so that is the obtuse angle there. So let's go to the next question. So the next question is question 19 from paper 058023 May June 2019. J, K, L, and M are points on the circumference of a circle with diameter JL. So if the diameter is JL, so okay, let me change the thickness of my ink. Okay, so that means this angle will be 90 degrees. Okay, this will be 90 degrees because this angle is produced or comes from the diameter, the two ends of this angle or the two arms come from this diameter, so it will be an angle in a semicircle. Okay, so JL and KM intersect at N, then angle JNK equals to 104 degrees and angle MLJ equals to 22 degrees. Work out the value of D, angle D. Okay, so since JL is the diameter, as I said earlier, so that means angle JML will be equals to 90 degrees. That is angles in a semicircle. Then we can start from triangle MJL. Okay, so we can get this. So we want to find this angle. So we know that this is already 90 degrees. So this angle and this angle are complementary angles. That is, they add up to 90 degrees. Okay, so we can say that MJL, that is this particular angle here, MJL, it will be equals to 90 degrees minus 22 degrees. And if you do that, that will give us 68 degrees. So that means the value of this angle here is 68 degrees. Okay, so but if you look at this angle MJL, okay, you see that it is also equal to this, okay, because they are angles in the same segment, okay, because they both come from the diameter ML or arc ML. Okay, sorry, arc ML, I meant to say, not diameter. Okay, so they both come from the arc ML. Okay, so ML is not diameter, it's a chord. Okay, so these two angles, this one here and this one here, okay, so are produced by this arc. So that means there are angles in the same segment. So if you trace it now, let's see, like this, that's the first one. Okay, so from here again, let's trace the second one. You can see that they always come back to this arc MN. Okay, so they are equal, so that will help us a lot. So I can say that MJL is equals to MKL, and that will be equals to 68 degrees. The two angles I just showed you. Okay, so if you look at here again, so you see that this angle MNL, angle MNL, so this particular one is also 104 degrees. Okay, so vertically opposite angles are equal. Okay, so that means this will also be 104. Okay, so I can put X here. So this one too will also be X because they are vertically opposite angles. So I can find the value of X now. So I know that this angle, this angle, this angle, and this angle add up to a 360 degrees because they are angles around a point. Okay, so I will say X plus 104 plus 104 equals to 360 degrees. So let's write. So instead of saying X plus X, we can say 2 times X, plus instead of saying 104 plus 104, we can say 2 into 104. Okay, so these four angles add up to 360 degrees. Then this will give us 2x plus 208 equals to 360 degrees. Then 2x will be equals to 360 degrees minus 208 degrees. Then 2x will be equals to 152 degrees, and x will be equals to 152 divided by 2. So that will be 76 degrees. Okay, so if you go back to the diagram, so that means this will be okay, I can clean this. This will be 76 degrees. So this will be 76 degrees too. And already I told you that this one will be 68 degrees because this and these are angles in the same segment. Then it is easy for us to get D now, okay, because D add 76 add 68 to become 180 degrees. That is sum of angles in a triangle. So you can say D add 76 degrees plus 68 degrees, okay, to be equals to 180 degrees. So D will be equals to, okay, I can just add these two first, plus 144 to be equals to 180 degrees. Then D is equals to 180 degrees minus 144. Then D is equals to 36 degrees. So that is the value of angle D. So you have 36 degrees here. Okay, so let's go to the next question. That will be question 19 from paper 058022 October November 2019. In the diagram, A, B, C, and D lie on the circumference of a circle center O. So O is the center of the circle. Angle ACD is equals to x degrees, and angle OAB is equals to 2x. Okay, find an expression in terms of x in the simplest form for the following angles. Okay, so let's start with angle AOB. So angle AOB, that is angle at center. Okay, so produced or subtended by this arc AB. Okay, so if we look at this very well, this is an angle at center, and the corresponding angle at the circumference will be this. Okay, so but unfortunately there is no relationship between them now, so we cannot connect them. But we know that OA is what is a radius, so and OB is also a radius. So if this place is 2x degrees, so automatically this will be 2x degrees. That is an isosceles triangle. So the base angles are equal. Then we cannot get the required angle AOB. So let's write here. So I can say 2x plus 2x, that's the base angles of the isosceles triangles, plus angle AOB will be equals to 180 degrees, sum of angles in a triangle. So these two add up to 4x plus, then I have angle AOB to be equals to 180 degrees. So that means angle AOB, okay, will be equals to 180 degrees minus 4x. Okay, so we can factor out 4 because 4 can go in the 2. So into brackets, that will be 45 minus x. So this is the final answer, but we want to leave your answer like this. Okay, so no trouble, you're still okay. Okay, so I think it's better to leave it like this. So let's write 180 minus 4x. Okay, then part B, angle ACB, angle ACB. So this is the angle here. So of course we know that this is angle at circumference and this is angle at center. So there's a connection between these two angles. So I can say angle at center, which we found to be 4. Okay, let's go down a little bit. Angle at center, which is 180 minus 4x. Okay, this angle is equals to 2 times angle at circumference, which is 2 times ACB. Okay, so then we need to divide both sides by 2. Okay, that will give us the value of angle ACB. So if we do this, this will be 90. Okay, then minus 2x. Okay, so 90 minus 2x, because 2 goes in 180 90 times and 2 goes in 4x 2x times. Okay, so we have that. Then part C, find angle DAB. If you go back to the diagram here, so this will be angle DAB. The whole of this angle from here to this place is angle DAB, and is inside this triangle DAB. Okay, so if we know only this angle from here to here, okay, so it will be very easy for us, because we know that this angle, which is 90 minus 2x, is the same as this angle, which is also 90 minus 2x. They are both angles in the same segment. Why? Simply because they both come from arc AB. Okay, so let's trace this one. Can you see it's from this arc AB, and let's trace the second one too. It's also from this arc AB. So they are angles in the same segment. Okay, then we don't know this particular angle that is from here to here. We don't know the value. So at the bin we have this value, then it will be very easy for us to get DAB straight away. So we only know from here, okay, to this place, which is more than this smaller angle. So this is 2x. That is, we only know angle ABO to be 2x. Okay, but we need angle ABD, which is smaller than ABO. Okay, so that means we cannot use this method. So we need to find another approach. Okay, so if you look at this shape here, this is cyclic quadrilateral. Okay, so you see that angle DAB, that is the whole of this angle. Okay, so plus this angle DCA, okay, will be equals to 180 degrees, because they are vertically opposite angles. And you know that vertically opposite angles of any cyclic quadrilateral are supplementary. Okay, so they add up to 180 degrees. So that means I can say DAB, okay, that's the angle, plus DCA should be equals to 180 degrees. Okay, so DAB, so will be equals to 180 degrees minus DCA. So that will be 180 minus DCA will be x plus 90 minus 2x. So that's minus, okay, so x plus 90 minus 2x. Okay, so let's expand the bracket. That will be 180, then minus x, okay, then minus 90, then plus 2x. If you open the bracket with minus, so that means 2x minus okay, you can take it like this: 180 minus 90 that will be 90 degrees, then minus x plus 2x, that will be plus x. So that is the value of angle DAB. So this will be 90 plus x. So let's go to the next question. That will be question 6 from paper 05 8043 October November 2019. Let's scroll down a little bit. In the diagram, A, B, C, and D lie. In the diagram, A, B, C, and D lie on the circle center O. Angle ADC is equals to 120 degrees. Angle ACD equals to 28 degrees, and angle BCO equals to 30 degrees. Show that the obtuse angle AOC is equals to 104. Give a reason for each step of your working. Okay, so we want to show that angle AOC, that is the obtuse angle AOC. Okay, so we want to show that it is equals to 104 degrees. So we need to mark the angle. So this is the obtuse AOC, this angle. So that is the angle we want to show that is equals to 104 degrees. Okay, so this is angle at center, and this is angle at circumference. Okay, so we can start from there. So we can say that AOC is equals to 2 ABC, that is this angle. Okay, and if you look at this very well, look at ABD. Let's see, D. So this particular angle here, okay, I can call it X. Okay, so if you trace it like this, it's coming from this arc AD. So if you trace this angle, okay, you see that it is equals to 28 degrees. Okay, so they are both angles in the same segment. So angle ABD, that is this angle from here to B, then back to D. So this angle is in the same segment as this angle ACD. Okay, so they both come from the arc AD. So that is how you can easily identify angles in the same segment. So I can say AB, okay, D, okay, is equals to ACD. You can see the arc AD here and the arc AD. Okay, so they must have the same arc. Okay, so they'll be equals to 28 degrees. So I have found angle ABD that I need already. ACD is given. Okay, so also if you look at it very well, look at angle DBC, angle D, then BC. So this particular angle here. Okay, so I can call this angle Y. Okay, so it's also equals to angle DAC. So they are both equal. Okay, so that means if I get this, I can easily get this. Okay, so from there, let's find angle DAC. Okay, you can easily get it because it's an angle in this triangle, and we already know the other two angles. So that means DAC will be equals to 180 degrees subtract 128 degrees subtract 28 degrees. So that will be 180 subtract 156 degrees, and that will be 24 degrees. So that means angle Y here is what? Okay, let's write it here first. 24 degrees, this angle DAC, and it is in the same segment as this angle. Okay, so this will also be 24 degrees. Okay, so don't forget that I've already found X to be 28 degrees. Okay, so this is 28 degrees. Okay, so I can get this whole angle, okay, which is the sum of 28 and 24. So I can go back to this first line, that is AOC will be equals to 2ABC. So 2 ABC will be the addition of these two angles, okay, because these two angles made this angle ABC, okay. So that will be 2 into bracket 28 plus 24, okay. Okay, so I can have AOC to be equals to 2 into bracket 52, okay, and if you expand the bracket, this will be 104, okay. So this has been shown, okay, okay. So let's go to Roman figure 2. Find angle BAO, angle BAO. So this angle here, so that is the angle you want to get. So how can we get this? Okay, it's pretty easy as well. So let's look into angle OCA, okay, and OAC. That is, this angle and this angle are what? They are equal. They are base angle of this isosceles triangle, and we just found this AOC to be 104. Okay, so it is easy for us to get these angles now. So I can put x here. This will be x. This angle from here to here is x. Automatically from here to here is also x. So I can say x plus 104, okay, is equals to 180 degrees. So that will be 2x plus 104 equals to 180 degrees. So that will be 2x equals to 180 degrees minus 104 degrees. So you have 2x to be equals to 76 degrees, and x will be equals to 76 over 2, which is equals to 38 degrees. Okay. So since we have this, okay, and we know that this angle DAC, we've already calculated that to be 24, okay, so that is DAC, and we know angle OAC now, which is 38 okay. So we can now use the concept of what vertically opposite angles of a cyclic quadrilateral. That is, we can say that angle BAD, the whole of this angle here, okay. So let's scroll down a little bit, and I'll write where you can see. So that is, we can say angle BAD, then add this angle BCD, that is the whole of this angle here, okay. Angle BCD, so add up to what? 180 degrees, okay. So let's start with angle BAD. So in angle BAD, we have three angles there. We have angle BAO, which is the unknown, okay. I'll write BAO, then plus the next angle after it is OAC, which we found to be 38, okay. So that is 38, then plus the last angle there will be angle CAD, which is 24 degrees. So these three angles made up angle BAD, plus let's go to angle BCD. So these three angles as well made up angle BAC. So that will be 30 plus x is 28. So that will be 30 plus 28 plus 38 plus 28. So that will be 30 plus 28 plus 38. Okay, so everything should add up to 180 degrees. Okay, so if you add all these numbers together, 38 add 24 add 30 add 28 add 38, you should get 158. So that means we are left with BAO plus 158, okay, to be equals to 180 degrees. Okay, so the reason I didn't scroll down is for you to see the diagram very well to understand the solution. Okay, so I can say BAO, okay, is now equals to 180 minus 158. So BAO will be equals to 22 degrees. So that's the value of BAO. Okay, so that will be 22 degrees. So next is the Roman figure 3 to find angle ABD. So let's go back to the diagram again. ABD. So I think I can remove this for you to see the letters very well, as well as this. So we want to find angle ADB. So let's check that again. Angle, yes, ABD. So that will be ABD. So it will be this small angle here. Okay, so fortunately we have that on ground, so it is 28. So we can just put the answer there, equals to 28 degrees. Okay, that is this particular angle from A through B to D. So this is 28 degrees. Okay, so let's go to the next question, which is the last question here. So this is question 1D from paper 058041, October, November 2019. A, B, C, and D lie on the circle center O with diameter AC. So diameter AC. So of course, if this is the diameter and the two legs or the two arms of this angle, okay, so go to AC, that means the whole of this will be 90 degrees. That is the implication. So I can write 90 degrees here. Okay, but always take note of the point as you are giving. Okay, so PQ is a tangent to the circle at A. So that means we should have angle between a tangent and a radius should be 90 degrees. That is, this will be the radius, OA will be the radius. That means this angle is 90 degrees. You can see, you can easily get angle U from here straight away. And also, you can get angles in alternate segments. Okay, that is the angle between a chord and a tangent. Okay, so will be angle in alternate segment with the corresponding angle. So the corresponding angle will be where's the line? Let's see. So this is the chord. Okay, this is this. Okay, so we can always get that. Let's see. We are using this chord, and we have this. Okay, but this angle will have been angle in alternate segment to this. But look at the chord that you are taking now. That is, you are taking angle U add angle 60. So that means you are using chord AC. So if this angle will be in the same segment, then the two arms or the two legs of angle B here must come from that arc. So unfortunately, one arm, which is A, okay, comes from that segment, but the other one is from D. So that means this can never be in alternate segment. So if you look at this angle B now, which has a value of W, okay, the two legs come from AD. Okay, that means we can use the chord AD. Okay, so let me remove this. That means this one, okay, and this one are angles in alternate segment. So angle 60 degrees will be equals to angle W degrees. That is angles in alternate segment. Okay, so that is how to get that answer. Okay, let's continue with the question. So angle PAD equals to 60 degrees and angle BAC equals to 20 degrees. Find the values of U, V, W, X, and Y. Okay, so pretty easy. I can easily get U here. So 60 degrees add U degrees, okay, will be equals to 90 degrees because you have angles, an angle between the tangent and the radius, okay, is 90 degrees, okay. So I can say angle U will be equals to 90 degrees minus 60 degrees. So U will be equals to 30 degrees. So that is super easy. So let's scroll down. u is equals to 30 degrees. Then I also highlighted something earlier, that is the angle between these, okay, that is, sorry, I didn't mark it completely. So the angle between the tangent and this chord, okay, so will be in the same segment as this angle, okay. So if you look at that chord, the two legs of the angle that will be in the same segment must come from that chord, okay. So that is W. So that means W is equals to 60 degrees, okay. So I can put 60 degrees here. Okay, so if I put 60 degrees here, so that may be helpful. Okay, so let's see angle V. So this is angle V. Angle V and W are in the same segment. Why? Because the both come from the arc AD. Okay, so if you trace this one, so from arc AD, and if you trace W again, okay, that is also from arc AD. So that means V is equals to W. So W is already 60. So that means V will also be 60 degrees. Okay, so I can put 60 degrees here. This is 60 degrees. Okay, so the next one will be we have angle X and angle Y. So where is angle X? Angle X is here. Okay, and we know that this is radius OA and OD is also radius. Okay, so we know that U is already 30. So this place will also be 30. So we can calculate X. So that will be the third angle in triangle OAD. So we can say that the base angles are 30 degrees each. So we can say 30 plus 30, 60 degrees plus X will be equals to 180 degrees. Okay, then we can now make X the subject of the formula. X equals to 180 degrees minus 60 degrees. So X will be equals to 120 degrees. So that's the value of X, 120 degrees. So we are left with Y. Okay, so I can put 120 degrees here, and to get Y now, if you look at what we have, so it's easy to get the value of Y when you make use of this triangle, that is triangle ABD. So I know that triangle angle ADB is made up of these two angles, that is 30 and Y, and I can get the whole of this angle, that is 30 plus 20, as U is equals to 30, and I know that W is equals to 60. So we can say that used from triangle ABD, 30 plus 20, that is U plus 20, that is angle A here. From here to here is U plus 20, and U is 30. So that will be 30 plus 20, okay, plus 20 plus, let's say the angle here is 30, that is 30 plus Y, okay, 30 plus Y, that is these two angles here, 30 and Y, then plus this one here, W, which is 60, that is plus 60 equals to 180 degrees. So if you add all these angles together, so 30 add 20 add 30 add 60 will be 140 degrees, then plus Y, okay, will be equals to 180 degrees. Then Y is equals to 180 degrees minus 40 degrees. So Y equals to 40 degrees. So let's scroll down and write the answer here. Okay, Y is equals to 40 degrees. Okay, so in the last question here will be this: A, B, and C lie on the center, lie on the circle center O. Okay, angle AOC, which is this, is given as 3x plus 22, and angle ABC, which is given as 5x degree. Okay, so find the value of x. Okay, so to get the value of x, so we know that angle at center, okay, this one, okay, is twice this one, okay, and this reflex angle and this obtuse angle add up to 360 degrees, right? From there we can find the reflex angle AOC. So by saying reflex angle AOC will be equals to 2 into bracket 5x, okay, so that will be 10x, okay, so this one is 10x, but we know that these two angles, that is the reflex angle AOC and the obtuse angle AOC, add up to 360 degrees because they are angles around a point. So I can say that 10 x add 3x add 22 is equals to 360 degrees. So let's scroll up a little bit. So this and this add up to 13x, okay, plus 22 equals to 360 degrees. So this one goes there and becomes negative. So we have 13x to be equals to 360 minus 22. We have 13x to be equals to 338. And if you divide both sides by 13, so x will be equals to 338 divided by 13, and that will be equals to 26. So the value of x equals to 26, okay, degrees. Okay, so this will be the end of part 2. So watch out for part 3. Until then, have your fingers crossed.